the new stuff. Anybody have any guesses who's next to go? Take your guesses, because we have to figure out which animal is going to live at the end of today's class. Right? So let's see who's next on the list to go. And it seems that it's Freddy the Froggy, right? So if you chose Freddy, he's out of the game. And today we will be moving on to something brand new in differentiation. We will be starting something called the product rule. Now, the product rule, although it's a new piece of theory, it's kind of based on everything we did so far in differentiation. We just can't say everything is brand new about it, right? Things are going to filter down from what we previously learned. So everyone take down this question, and over here we have what we call the product rule, and I'll explain when it's appropriate to also use the product rule. So take a few seconds there. All right, so let's explain how to use the product rule. And the good news is the product rule, this rule over here, it's actually written on the past paper itself, on the exam paper itself. It's part of the formula sheet. We specifically use the product rule when you have two groups of x being multiplied. Look at this. Over here, we have 2x. And of course, there's a secret multiplier in between here. And over here, we have another group of x. So it's, remember, the word product means to what? Multiply. So only use the product rule if you have two different groups of x being multiplied by each other. So what we need to do now, the two groups of x, the first group, we just always call it u. In other words, u is equal to 2x. And the second group, we call it v. You will notice that the formula for the product rule has things like u and v in it. So I'm showing you where the u and v comes from, right? Take them up to there, right? First group is always called u. The second group is always called v. So let's write down what we have so far. It seems that we are calling u equal to 2x, because that is what we said. U is equal to 2x. And v is equal to the other group, which is 3x minus 5. Well, this one is in brackets. And the whole thing is being held hostage by the power 4. Take down up to there. And so two groups. Now, if you look at the formula, it has things like u. We know how much u is. They ask us what v is, but we know what v is. And this dot means multiply. But we also need to get things like dv dx and du dx. So where does dv dx and du dx come from? It's very, very simple. For example, if I have u and x, if I differentiate u and x, I will get what? Du dx. When I differentiate 2x, remember last week I showed you a shortcut. If something only has x, like just x to the power 1, not x squared, not x cubed, just regular boring x. When you differentiate this, you're just left with the number in front. So we will get 2. When we differentiate v and x, we're going to get dv dx. Now here we can use the shortcut. We could throw the power in front, so we'll get 4. What do we have to do with the power? We minus 1 from the power, so we will get 3. And we also differentiate whatever is in the brackets and throw it outside. If we differentiate 3x, we'll be left with 3. 5 is a constant. When we differentiate a constant with no x's, you get 0. So the point is, when we differentiate this entire expression, we get 3. So the 3 also goes outside. Now, this can obviously simplify. 4 multiplied by 3 is what? 12. All right, so I would eventually change this to 12, but everyone take down what we have so far. Right, so I'm just going to simply, just to make things easier, 4 multiplied by 3 is 12. Right, now this is as simple as we can get. I know some people might say, let's multiply everyone inside here by 12, because that's what you normally do with brackets. But this bracket is being held hostage by the power 3. So unfortunately, this 12 cannot multiply by everyone inside here. This is as simple as this will get. So let's put everything together now. To find dy dx, we have to put all 4 things together. The first one is u. How much is u? Well, we have u here. U is 2x. And then we have to multiply it by dv dx, right? Now, if I'm going to multiply it, I'll just put dv dx in brackets. Where's dv dx? dv dx is over here. 12, well, this is brackets within brackets, unfortunately. I'll put the brackets last, right? So we have to multiply it by 12, open brackets, 3x minus 5, close brackets, 3. But I have to put this whole thing in brackets, right? Plus, how much is v? Where's v? V is this guy here. 3x minus 5 to the power 4. And then we have to multiply this by du dx. du dx is 2x. Right, now there's very little we can do to simplify this. The most we could do is multiply the 2x by the 12. I cannot even take the 2x and multiply it by this here. The 2x only gets multiplied by the 12. You will get 24x. And you have the 3x minus 5 to the power 3. There's nothing really much you can do here. I would just put the 2x in front rather than have it behind. But if you leave it here, it's just as correct. And this is as simple as you can get this expression. I would leave it like that, and I will get full marks in the exam, right? Like I said, there's nothing much you can do, right? Everybody understand so far? Well, that's the end of the question. I mean, understand everything to get out these questions. I'll watch you wrong, please. And 2 people told me, du dx is how much? I made a mistake. Look at it. Du dx is 2. I put 2x by mistake. So that's my fault. This should just be what? 2. So I should just have a 2 over here. Apologies. Right? So for those who spotted it, great job. Let's see what's next here. Question 2. All right. So this question over here, you will notice it's 2 groups of x again, right? You have the square root of 3x. That's one group. And the sine 4x is another group. And of course, there's a secret multiply in between it. So we have grounds to use the product rule. Just one small thing, right? We should probably rewrite it like this to make it easier for us when the examiner gives this to us like this. Square root is the same thing as to the power how much? A half. And we're multiplying this by sine 4x. So the first group is going to be u, and the second group is going to be v. Give this one a try. You don't have to get it 100% correct, but if you get like, over 70% of it correct, that means you're on the right track. And by the time we do a few examples more after this, you'll have everything completely done. But give it a try. And of course, you don't have to send the answer on the chat for this one. It would just be too much to type. Just let me know when you are finished. We said that we are going to let the first part be u. So u is going to be 3x to the power a half, and v is going to be sine, 4x. So we need to differentiate both items. When we differentiate the first one, we're going to get du dx. Now this one is pretty simple to differentiate. You throw the half in front, right? So when you throw the half in front, right, you have to minus 1 from the power, right? So you will get minus a half. Now we could no, actually I don't think we can simplify this, right? Throw the half in front, right? So let's leave it like this. How much people had up to there? You throw the half in front and it is minus 1 from it. But don't we have a small, and that's a trick question. Don't we have something missing from that? Well, what do you think we're missing from that? Remember, we have to differentiate whatever in the brackets also, right? And we have to throw that outside. Let me explain, right? And this is a subtle difference. If I had 3x and the x alone was to the power a half, the x alone, like the half does not belong to the 3. Well, what do? We throw the half in front, right? We throw the half in front and then we minus 1 from the half. Everyone agrees with that, right? But this situation is a little bit different. Look at it. I'm going to draw a line here. It's 3x and the whole thing is to the power a half. So when you throw the half in front, fine, not a problem. We have to minus 1 from the half. But because this whole thing belongs to the half, we also have to differentiate what's in the brackets. And when you differentiate 3x, you will get 3. And he also goes outside. How much people forgot to throw an extra 3 outside there now? Right? There's a subtle difference between these two questions. Subtle difference. All right? So the 3 also has to go outside to join the half. So it's a half and the 3 goes here. Now, don't leave it like this, right? We all know a half multiplied by 3 is 1.5 or 3 on 2. So let's just simplify this one time, right? A half of 3 is 1.5. Nothing wrong with putting it in a decimal form. Great. So let's do the other part now. dv dx. This one is easy. We did a few like this last week. When you differentiate sine, you get positive cosine. You put back the 4x here, and you have to differentiate this as well. Whoever is touching the x goes outside as well. How much people got this one? This one should have been super easy. You will get 4 cos 4x because it's straight out of last week, no tricks. Great. So all we have to do now is put everything together. Everything. All 4 things. So dy dx is equal to u. Where is u? U is 3x in brackets to the power a half. Multiply by what? dv dx. Where's dv dx? dv dx is this guy here. 4 cos 4x. Put the plus sign with v. V is sine 4x. And du dx is this here. 1.5. That's now 3x running out of space minus a half there. Right? There's nothing much we can actually do here to simplify this mess. Right? There's really not much we can do. If I had to try to simplify it, I'm just saying, if instead of having the 4 here, I would put him here. You don't have to. I'm just saying if you wanted to. Just to make it look a little bit neater. I don't like having numbers in between expressions. No. So this 1.5, you can put in first, I guess. and you have sine 4x, and in brackets here you have 3x to the power minus a half. All right, right? So this is the answer I would put in the exam. How much? Well, I'm guessing a lot of people got this wrong because they fell for the trick over here, where you forgot to put the 3 outside as well, right? But how much of you all got the majority of it correct? It was just that small trick that got you. All right. Now, in this particular question, right? You see how I have this -1 here? Now, that's supposed to be to the power -1. I don't know why it came out so large. But this -1, you notice it's not, the 3x is not in brackets. So this -1 only belongs to the x, which is good news, because when it only belongs to the x, then you can just differentiate it as normal. That's not the trick in this question. There's a very, very, very small trick in this question. Try it, and when I work it out, you'll let me know if you fell for the trick. Okay? Let me know when you're finished, as usual. We put it in. So there's 2 groups of x here, right? So the first group, that's this guy here, he's going to be u, and the cosine is going to be what? V. I think that was obvious. So u is going to be 3x to the power -1, and v is cos pi minus x. Let's differentiate the easy one first. du dx. This one here, the power only belongs to the x, so that's good news. You throw the -1 in front, the -1 will be multiplied by the 3, so you will get -3, and then you -1 from the power. -1 minus another 1 is -2. I think the majority of people will have everything correct here, the minus sign here, and also the -2. I'm pretty sure, well, 99% of the class will have it correct. But the other one, I know is going to cause some problems. So before I differentiate dv dx, let's do some examples that will help you understand where I'm coming from. If I have y is equal to cos 2x plus 3. Now, if you look back in your formulas, when you differentiate cosine, right, you get what? Minus sine. So you'll get minus sine, and you write back everything here, 2x plus 3. But with one small exception. Whoever is touching the x also goes over here, right? So just take a quick look back at your formulas. You notice the 3 does not have an x, okay? So there's nothing to do with the 3. You just write back the 2x plus 3. It's only the 2 that's going to go outside. Look at this carefully, right? You have cosine pi minus x. Now, I know you're not seeing anything in front here, and also the x comes second, but it doesn't matter if the x comes first or the x comes second. The point is, when we differentiate it, whoever is touching x goes outside as well. What do we have touching the x here? Don't we have a -1x? Just nobody bothered to put what? The 1. So when you differentiate the cosine, you will get minus what? Sine. You write back the pi minus x. But who is touching the x? -1. So the -1 also goes outside. And a minus will touch to give you what? A positive. So you actually end up getting a positive on the outside because of the -1 over here. So at the end of the day, you don't even have to write the +1, because if I write nothing here, it is automatically +1. How much people could say they fell for that trick? They got that part wrong. Be honest. Let me see on the chat there. Everything together. right? So trying to find dy dx. U is 3x to the power minus 1 multiplied by dv dx. That's just sine, open brackets, pi minus x plus v. Where is v? V is cos pi minus x and du dx. Now du dx is minus 3x to the power minus 2. Now, well, what could happen? We could just put the minus 3 first, right? So you'll make it look a little bit neater. So we can move this minus 3, right? And put him over here to make it look neater, right? And we just, well, I should have this little space here. I'll put the x to the power minus 2. All right. If you had left the minus 3 here, I don't think the examiner is going to minus any marks, but it looks so much neater to have the minus 3 first. Right? All right. Yes, I want to answer one question like this, right? When we were doing trigs, tell me something, guys. Is it okay for trigs to multiply out every one inside here by cos? Is it okay to say cos pi minus cos x? That's 100% not allowed. Whenever the brackets comes in front, you cannot multiply out a trig function. All right, that's just not allowed in maths, right? Now, don't get me wrong. If I had pi minus x, the brackets came first, and then I had, let's say, cos x here. I know that looks strange. Fine. In this case here, you can multiply every one inside here by cos x. But look how I'm going to write it. The pi gets multiplied by the cos x, and this minus x gets multiplied by the cos x. You notice where I placed the pi and the x, it came before the cos x. You try not to write it like this, right? So, and this one is it takes a little while to get used to, but trig functions, if the brackets comes in front, please don't ever, 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 ever think you can multiply it out. It's just not allowed in maths. All right, so Videsh, that clears up the question. All right, so we have the next cutscene here. Who do you think is next to go, guys? Who will meet their maker today? Is it Tony the toucan, Alan the alligator, Sally the snake, or Paul the parrot? I see there's a lot of hate for Alan. Like a lot of people want Alan to just go. All right, so let's see who's next on the list here. And it seems it's Paul the parrot, right? Apparently, he was in the Amazon mafia, and for some reason, he couldn't keep his mouth quiet. But he's a parrot. What did they expect? All right, so say bye-bye, Paul. So there are 3 more people left. Tony, the toucan, Alan, the alligator, and Sally, the snake. We'll see who makes it out alive. So now we're going to do something called the quotient rule. Now, the quotient rule, you can think of it as the opposite of the product rule. The product rule is used when 2 groups of x are being multiplied. The quotient rule is when 2 groups of x are being divided. And the formula is a little bit scarier looking, right? This is the formula. But the good news is you just have to find everything in the formula and just slap it together. That is all you have to do. And you'll notice in today's question, you have 1 group of x on top and 1 group of x underneath. So the top group, we always call it u. And the underneath one, we call it v. You all want to take a try at this first? It's not going to be hard. You just have to find du dx, dv dx, and you just throw everything in the formula. You don't have to attempt to simplify it too much, right? You just put everything together, and if it is possible to simplify it, we will try a thing, all right? But give it a try, and you're going to realize it's really not too difficult. And the formula is given on the formula sheet. So the top section is u. So u is x cubed. V is the underneath portion, which is 2x minus 5. Du dx. If we differentiate this expression, this one is easy. Just throw the 3 in front, minus 1 from the power. Dv dx is also pretty easy. When you differentiate 2x, you will just get 2. And when you differentiate minus 5, well, that's a constant. So you're going to get what? 0. So it's just to throw everything inside here. Dy dx is equal to v. Where's v? V is this guy here. 2x minus 5. I'll put him in brackets just in case. Du dx is what? 3x squared minus, this one has a minus sign, u, where is u? X cubed and dv dx. That's this guy here. He's just 2. Right? So you can put the 2 in front, so it will look funny, right? It will be 2x cubed instead of x cubed 2. And the whole thing is divided by v squared. Now you have to write it like this, right? The whole v, this is this expression, you have to put it in brackets and put a squared. How much people got that basically? If you put the 2 in front rather than last, obviously it's still correct. How that looking? Right? I won't bother to attempt to simplify this, right? So, right, pretty easy, right? It's pretty much like the product rule, except a slightly different formula. All right, so let's move on. All right, slightly harder question, waiting, right? Remember, square root is the same thing as to the power a half. It's a small startup. The top group call it U, the underneath group call it V. Get started, right? Let's see if you fall for the slight trick. But I think I gave it away, the square root part. Right. So we're going to let U be equal to sine, well, 3x. And V, I'm just going to change the square root 1 time to a half, to the power a half. Differentiate U, and to get du dx. When you differentiate sine, you get positive cosine, and whoever is touching x also goes outside. So you'll get 3 cosine 3x. This one here, I'm going to use the shortcut, right? Throw the half in front, right? Minus 1 from the power, so I'll get minus a half. And when you differentiate whatever's inside the brackets, throw it outside as well. Now, when you differentiate 4x, you're going to get 4. And when you differentiate 1, well, you're going to get 0. So only the 4 makes it outside. And you could simplify this, right? Because we know a half of 4 is what? 2. But I'll erase it just now, right? So how much people had up to there correct at least? I have a good feeling when we put this together, it's not going to look too good, right? So a half by 4 is 2. So I'm just going to leave this as 2 here. Dy dx. V is 4x plus 1 to the power a half. Multiply that by du dx. So that's sine 3x minus, the formula has a minus. Where's u? Sine 3x, that's this guy here, and dv dx. Well, this is 2 open brackets 4x plus 1 to the power minus a half. I don't like how this 2 is in the middle of both expressions, so I'm just going to move him to the front here, right? Right, and obviously there's a multiply in between these 2 items. And where's v? V squared. 4x plus 1 to the power a half. Now, in case you didn't notice, right? If you have 2 things in maths, like x to the power a and it's to the power b, when 2 powers are separated by brackets, it's okay to multiply the powers. So that means if I have 4x plus 1 to the power a half. And the formula tells me I have to square that entire expression. Isn't the half and the squared separated by brackets? 2 powers separated by brackets. A half by 2 is 1. So this whole thing becomes to the power 1. But when you have something to the power 1, it's like nothing, right? So you don't even have to put the brackets. I mean, you can leave the brackets if you want to, and the power 1 will be understood, right? So this is a little refresher from Form 3 maths there. When 2 powers are separated by brackets, it's okay to multiply them. How much people got that answer? Right? I don't know if the brackets separating the powers got you. I don't know, right? But you'll let me know. Oh, someone said something. I did something wrong. Oy. Anybody else spotted the mistake? It was just I wrote the wrong thing. Du dx is how much? 3 cos 3x. Look at what I put by mistake. So for the person who spotted it, du dx is actually this. I put this by mistake. Second time for the day I did it. So it's supposed to be 3 cos 3x. And if you want, right, you could put the 3 in front to make it look a little bit neater. Okay? So for the person who spotted it, thank you. Right? So you can feel free to give me feedback on it now if you really got it 100% correct now. Go on. Oh, cutscene. Who is next to go? Who is next? Sally, Alan, or Tony? Let's see who's next to go. Right? And it seems like it's Alan the alligator. He went exploring and he got caught, well, lost in a cave. And you know those giant cave spiders always around. They got Alan. Right? So bye-bye, Alan. So the 2 people left are Tony and Sally. Anybody still in the game? Like, did their character not die off as yet? All right. So Kenya, I assume that you're still in the game. Zachary, right? You're still in the game. Rebecca, you're still in the game, right? No, Shifter, this was a giant spider. Way bigger than Alan. All right. All right, so here we have a very unique question, right? Examiners love to bring this particular question in the exam. Take down this question and we have to try to differentiate tan x. And I want to explain to you why we have to use the quotient rule for this. And you'll need to turn back to last term's notes in order to understand why. All right, so if you look at your notes, right, I showed you how to differentiate sine. Like when you differentiate sine, you get what? Cosine. When you differentiate cosine, you get what? Minus sine. In any of the formulas, you'll notice, you don't find it strange that I left out tan? Look in your notes. Can you verify that I did not give you a formula to differentiate tan? Just verify that for me. Look back from the formulas from last week. I don't think that there's any formula that was given that could differentiate tan. Only cosine and sine were given, right? You will notice that, right? Right. So I'm going to show you how to differentiate tan now. If you look back in last term's notes, you all would have seen this formula that tan is the same thing as sine divided by cosine. When we did trigonometry, if you see tan anywhere in a question and you don't like it, it's perfectly okay to throw it away and replace it with sine divided by cosine. So you'll realize this turns into a quotient rule question now. The top is U and the underneath is what? V. You could use the quotient rule now to divide this. So get started up on it. Might help you a little bit here. U is the same thing as sine x is the top and the underneath is what? cosine. Give you a few minutes for that one. Right? And the examiner loves to ask this particular question. So we're going to differentiate u first, du dx. When you differentiate sine, you just get regular boring cosine. And when you differentiate v, when you differentiate cosine, you get minus sine. So we just have to throw everything together now. dy dx. V, let me see if I make no mistakes this time. V is cos x. Du dx is this guy here. So he's another cos x minus u, which is sine x. And dv dx is minus sine x. And this whole thing is divided by v squared. Where's v? Where's v? Cos x. So it's cos x, well, squared. All right, so how much people have up to there, right? At least this could simplify, like I said, right? This can more than simplify. Cos x multiplied by a next cos x is cos squared x, right? Now you can write cos, last term I showed you can write cos squared x like this, or you can just put it above the s, right? Most textbooks will write it like this. Minus multiplied by next minus is a plus. Sine multiplied by sine is sine squared x. And underneath we have cos x squared, so cos squared x. Look back in last term's notes. Whenever you see cos squared x plus sine squared x, what can you replace that expression with? What can you replace that with? That's a formula I gave you last term. Right? And a lot of people are just telling me the answer, 1, right? Cos squared x plus sine squared x will always give you 1. So the answer is 1 divided by cos squared x. That's the final answer. So whenever you differentiate tan, you always get 1 divided by cos squared x. But in the exam, you have to show them all the steps, right? So take down that and well, take a half a minute and then we'll move on. Let's see. Oh, next cutscene. Right, so I guess now we'll know who actually wins the game. Who you think is going to die now? Tony or Sally? Right, so let's see if you all choose the correct person from the beginning. And it seems that the winner is Sally the snake. Sally poisoned Tony so she could win the game. How much people chose Sally from the beginning? Like you didn't make Kenya, you got it, right? Rebecca, you got it. Farika got it. Zachary, Jonathan. All right, guys. So congratulations to those who won the game, right? All right. So we're going to move on now to something called stationary points, right? Now, stationary points, we can't actually finish it today, but we should make some good headway into it, right? So just 1 second. Now, before we move to stationary points, I just want to refresh your memory that whenever you're finding dy dx, that dy dx is the same exact thing as gradient. When you differentiate something once, you are just trying to find an expression for the gradient. Now, here's the thing about curves. Now, well, let's start with a straight line. Everybody knows how to find the gradient of a straight line. I think we did this in regular boring maths. When you have a straight line and they give you 2 points on the line, let's say this is the line here, to find the gradient, and usually symbol for gradient is the letter m, but you can also use dy dx, but nobody in regular boring maths going to put dy dx, so just use the letter m. This formula is the one that you normally use. How much of you all remember this formula? Now, this is the formula to find the gradient or dy dx of a straight line, right? Now, a straight line right? The gradient is the same at each point. Like if a person is walking up this line, the gradient never changes. The steepness never changes. So finding the gradient of a straight line is pretty simple. That's why it has such an easy formula. But a curve, if you have a mountain shape like this, the mountain going up like this, that's a little better. Like you have a little slope here, and then the mountain goes up like this, and then it comes back down. If somebody is walking up this curve, like I said, let's pretend it's a mountain. You all notice that the steepness changes at different points on the curve. Here is not so steep. In other words, the gradient is small. Then all of a sudden, the gradient just sharply increases. And then, of course, the gradient becomes negative and goes downwards. The point is, in a curve, the gradient continuously changes. So using y2 minus y1 divided by x2 minus x1 is probably not the best idea to find the gradient on a curve. So when it comes to a curve, if you want to find the gradient at a certain point, you're forced to differentiate. So here you are given a curve, right? And they want you to find the gradient at a particular point. This is the x coordinate and this is the y coordinate. All you need to do is differentiate this expression and replace the letter x with 3. That's all you have to do, because you want to find the gradient when the x value is 3. Do you all think you all can do that for me? Differentiate this expression, whatever you get, replace the x with 3, and send the answer to me, right? Most likely, I have a good feeling you're going to get a decimal. So try to round it off to 2 decimal places. All right, so when you differentiate this, well, let me write it back. Remember, this is really 4x cubed minus 3x to the power a half, because square root is the same thing as a half. When you differentiate this portion, remember, this portion is completely separated from this portion. So you can differentiate each portion separately. Throw the 3 in front. The 3 meets the 4. You're going to get 12x squared. Throw the half in front, and the half will meet the 3. A half of 3 is 1.5, and you're minus 1 from here. How much people got that expression? Because if you get the expression wrong, then everything else is going to be what? Wrong from there. Now, you want to find the gradient at 3, 2. So you're pretending the x value is 3. So you're just substituting x is 3 inside here. Or the x's, right? And this is to the power minus a half. If you don't like the minus a half, you can put 0.5 on your calculator. So let me type this in on my calculator. 12 multiplied by 3 squared minus, minus 1.5 multiplied by 3 to the power 0.5 minus. And I actually getting this 107.13. I'm going to double check it, right? I'm going to double check it here. Now, so far, I haven't explained what is a stationary point. You realize that, right? The main topic that we're focusing on now is stationary points. But I haven't actually told you what a stationary point is. Here we have a curve again, like a mountain going up, a mountain going down. Where do you think would be the easiest part of the mountain to walk on? Like the person is walking up, right? So the person walking this way. At point A, at point B, at point C, D, or E, or even F. Where would be the easiest? Well, where would you sweat the least? Right? Where? Right? It actually have 2 easy points to walk. Pretend you're climbing this mountain, you're walking. Where's going to be easy? Right. The easiest places to walk, but it's not A, because A real steep. But when you reach B, it won't here be real easy to walk because it's almost flat over here. C is still going to be hard to walk because you're walking down a steep slope. Let me slope, that's not a word. Slope. Yeah, you have to kind of like break yourself from rolling down the hill. So B is going to be easy. And at point D is definitely going to be easy. And at this turning point here, right? You notice it's going down and then it's going up. Won't D also be real easy to walk? Think about it. B and D are the two easiest places to walk. You all know why? Because the gradient at point B and the gradient at point D is 0, right? Stationary points are points on a curve where the gradient is 0. Make a note, right? Or it over here, right? And they also call stationary points turning points. And I want to explain why they call it turning points. At point B, just before point B, weren't we going up? But when we just passed point B, aren't we going down? Aren't we turning our direction from up to down? And the same thing happens at point D. First, you're going downwards, and as soon as you pass D, you're going upwards. So B and D are turning points, better known as stationary points. And at stationary points, your gradient is 0. Now, if your gradient is 0, then since gradient and dy dx is the same thing, then dy dx is what? 0. So whenever you hear the term stationary point or turning points, you know the question would have to do something about differentiating. And when you differentiate it and get dy dx, you're going to have to put it equal to 0. Right, so let me know when you're finished with, but oh, there's something on the screen here, right? This is going to take a little while. You have to do examples to really catch the hang of this. If you have y and you differentiate y once, we all know we're going to get what? Dy dx. But what happens if we grab dy dx and decide to differentiate dy dx again? When you differentiate twice, you just get something called d squared y dx squared, right? Now, here's the thing. Point B is what you call a maximum stationary point. It makes sense because this is like the highest point on the mountain. A maximum is go up and then go down. Point D is what you call a minimum stationary point. Minimums go down first and then go up. To know whenever the examiner asks you to find a stationary point and you don't have a graph to physically see which one is the maximum and which one is the minimum, there's a real easy way to figure it out. Whenever d squared y dx squared is positive, you get a minimum. You have to note that because a lot of people associate positive with a maximum. But d squared y dx squared, if you get a positive value, like when you differentiate it twice, if you get a positive value, that particular point is a minimum. If your d squared y dx squared is a negative, that point is actually a maximum. Now, these are just words on the screen for the time being. You're only going to truly understand this when we do an example. All right, so let me know when you're finished with everything on the screen, and we will move on.